Hi everyone, this is our Chem 120 video project on the chemist and scientist Richard Zsigmondy. This is a brief overview of what we will be covering in the video. Part 1 will be the bibliography covering his childhood, schools and study, brief overview of his research, marriage and works. Part 2 will be more in depth about his research, his invention and how he got the Nobel Prize. And Part 3 will be focusing on his research contribution and importance. Zsigmondy was born in Vienna on April 1, 1865. When he was young, some of his childhood hobbies were tree climbing, mountaineering, swimming, and diving. His father also encouraged him and his sibling towards many of the natural sciences. At an early age, he became interested in chemistry and physics. He also carried out many experiments in chemistry textbooks. Zsigmondy first learned his basic facts of quantitative analysis under Professor E. Lewig, and in 1887 he read organic chemistry under Professor W. von Miller. In 1889 he received his doctorate from the University of Munich. He also studied at Technische Hochschule in Vienna and became a lecturer there in 1893. Zsigmondy worked on colors for glass and became wrapped in the chemistry of colloids. He eventually met up with Scotch Glass Manufacturing Company to learn more about the glass in Jena and remained there until 1900. Later he left so he could pursue his study on the chemistry of colloids. During this time, he discovered how to prepare reproducibly gold hydrosol and developed the slit ultra microscope with seed and tope. In 1903, Zsigmondy married Professor Wilhelm Noah's daughter, Laura Louise. They both had two daughters named Anna Marie and Kathy. In 1908, he became the director of the Institute of Inorganic Chemistry at the University of Göttingen, and he retired from this in 1929. Shortly after Zsigmondy retired from the University of Göttingen, he died in Göttingen on September 23, 1929. In his honor, the crater Zsigmondy on the Moon is named after him. Now we're going to focus more on his research. Due to Zsigmondy's interest in colloidal substances containing particles of gold that produce different colors in glass, Zsigmondy's research focused on the following: colloids and its properties, purple of Cassius, invention of immersion ultra microscope. So, what are colloids? Colloids are submicroscopic particles that are dispersed in an aqueous solution. Some of its properties are, when in solution, they are larger than the molecules and are frequently regarded as the derivative of the molecules. They also vary in size when dealing with the solution of the same substances. Examples of colloidal systems are milk, aerosol gel, detergent, paint, and foam. Part of Zsigmondy's research also focused on the purple of Cassius. This was discovered by another chemist named Andreas Cassius. It was made from a mixture of finely divided gold and stannic acid. When it was first synthesized, gold was precipitated until it became a color of purple with a tint of red. This was then used to place color on ceramic to obtain the color red, which was then called ruby red glass. It became recognized as a dye for glass melts in ceramic without its colloidal properties being known, until in 1902 when Zsigmondy used the ultra microscope to prove that the purple Cassius pigment was actually a colloidal solution. One of the most important parts of Zsigmondy's research was the ultra microscope. This was invented in 1902 by Zsigmondy and Tope. This device followed the principle of dark field illumination, in which light passes through the solution under the microscope at right angles to the observer. The resulting effect is similar to that obtained when a beam of sunlight is absorbed to a closed room through a small window. Although invisible to the strongest conventional microscope, small particles that are a 10th millionth of a milliliter in size are now visible. Limitations of this spectroscopy are in gel structure, which are very small that their observation is no longer accessible to the ultramicroscopy. Such systems occur in the dry gel of the salicylic acid. The following video is a demonstration of the ultramicroscope. Please follow along as it plays. In 1925, Richard Zsigmondy won a Nobel Prize in Chemistry for his invention of the ultramicroscope and for his research of the colloidal system. This was at the height of his career. Richard Zsigmondy's invention and research helped make many important impacts in the science world. Zsigmondy's invention of the ultramicroscope helped prove that purple is a colloidal substance. The ultramicroscope also helped make coagulation observation possible. With the help of organic chemist Max von Somocholsky, a mathematical formula of colloidal coagulation for gold colloidal solution and other colloids was created. Richard Zsigmondy's invention and research is of great importance. Colloids have relevance to the field of medicine and agriculture. It also became very helpful in the field of biochemistry and bacteriology. Within years of the ultramicroscope invention, scientists were able to use it to plot particle movement as well as count and measure particle size. Nowadays, different types of ultramicroscope have been used to monitor air quality, water usage in industry, as well as drinking, and for checking contamination degree due to impurities. It has definitely revolutionized our understanding of the world. This concludes our video project on the scientist Richard Zsigmondy. Thank you for watching and we hope you enjoyed. The following are references that we used in the making of this video. Thank you.